Welcome back to the video on functions. And in this video, we are going to talk a little bit more about functions. And today we are going to discuss how functions actually work inside the main function, which is actually the stack as shown over here in this slide in front of you. Just to give you a reminder, in the last video, we discussed that whenever a function is called, the value is actually, or the copy of that value is actually passed. That's why it's called as by pass by value. So here inside this main function, whenever this function is being called over there and it has this value is actually a variable which has a value 5. So this 5 is actually copied over there. So when this function is going to be printed, it will be printing that value of 5 over there. But afterwards, when the control comes back to the main function, then if it is again printed, then this time it will be, the value will be printed as 5 over there. So this means that inside the function, the value changes to that 100 over there, whatever is initialized over there, and then it is equal to that num over there. So only the value is copied over there. This was done, we did last time over there. Today we are discussing the function called stack. Now, what is this stack? Now, just before I go on proceed and tell you what is its working inside the C language of the function, very importantly, just to give you an analogy, whenever you are supposedly in a kitchen or you are somewhere and you have a rack where you are actually going to put all your dishes one by one on top of each other. Supposedly, if you're just going to wash those dishes over there, so on one dish, on another plate, you rack up all the plates on top of each other. So the plate which you have kept on the extreme top just now, if you start washing it, you are actually going to wash the one plate which you have just put it recently. This is a kind of a stack. And in this stack, whatever you are going to push latest, that is going to be first time out. And that kind of a stack is called as last in, first out. That is called as LIFO. Now, there are some kinds of, if you have been to a hotel or somewhere, you must have seen somewhere that the plates are racked on top of each other. And if you want to take some dish, you are going to take it from the bottom. That will be called as a first in, first out, because that lowest plate was on the lowest point. It was put first of all, then afterwards you put it one, two, three, four, five, six, seven. You are increasing the number of plates on top of each other. So that's, you are going to take the plates from the bottom. That's why it's going to be called as FIFO. That is going to be first in, first out. But here, the C language, it has a stack for variables. Again, remember, stack is just like a library or a rack of plates, you could call it, where you're going to place your variables. Because why a stack is required? Practically, first of all, a stack is required because you are actually going to go towards another part of program and you have to save all your variables because they were working in some other function. So you want to restore them back when you come back. So you have to place that variables on some stack. So all those variables are going to be pushed on that stack or on that rack over there. And then when you come back, you are going to have whatever you put it just recently, you're going to get it out. And that's why it's called as the last in, first out. So you go just, think of a stack of plates. The example is again same given over there on this slide. You add a plate on the top and you remove the plate from the top. That is called as a push because you are pushing the plate on the top and then you pop, which means you are going to take that plate from the top over there. And in here, the plate is actually the variable, or it's actually on the plate. They are variables which are stored on the stack, and the control is given to the other function. You do whatever that function is doing, and then you come back and take all those variables. That's why here in this case, when you went to this variables function, whatever function was being processed, that variable value, that was value is equal to 5, was pushed onto the stack. Control went to this function over here, which I'm highlighting. Here, the value of 100 is being printed over there. And when you come back over there, the same value is now being printed over there. That is this point. So you are seeing over there that whenever you are actually having a stack over there, the C language works on the stack, which is called as last in, first out, LIFO. I will give you an example when this course progresses about the first in, first out stack as well. That's a totally different stack that is normally done for interrupts. First in, first out. I will talk about that. That's actually called as an interrupt service routine, ISR. But at present, I'm not talking about that ISR at present. This is just a simple stack which is based on last in, first out. So whenever a function is called, you push the info. Here, info is actually the variables. What does the info includes? It includes a return address. What does return address here mean? Return address means that this function was called here. This line number 11 was called here. So when this function will be processed, that is above over here on line number 3 to 6 over there, or 3 to 5, then the return address will be the line number 12, because line number 12 have to be printed after that. So that will be the return address, because now the control has to come back to this line number 12 over there. So when the function returns, which means the function has returned, supposedly if it is a return type function, it's not void over there, then you pop the info from the stack, whatever variables you had over there, you just bring them back, and the previous function continues where it left off. Now here the previous function is the main function. That's why it's also a function. So it's the main function. That's why you are going from one function to another. Now it may be possible that inside the function you call another function, and inside that function you call another function. So you will have a stack of variables from one function to another function to another function to another. So it's not like this that you're in the main function, you will call one function, you can call another function from the second function also. So this can go endlessly. So that's why the stack is based on last in, first out. So whoever has put the plate at the last will be taking up firstly. So that's why it's called as the last in, first out, or LIFO. Then I guess in this same example, you can see over there, it's a very good example shown over there. This is the main function. Here int a is equal to 10, int result, there are two variables, a is 10, result is having no value, no initialization. Result is equal to square of a. So what is being done in the square function? You are returning x into x. We're just giving the square of that function or that value, whichever is giving it. So when you call square a is 10, you put 10 over there. So 10 into 10, that becomes 100. So now that result is equal to 100. That result is equal to 100. But at the same time, A is not changed. A is still 10 because the value of A was copied over there on line number 8, the value variable. But when the control went from this line number 8 to this line number 1, 2, 3 over there, the value of A was put over there on the stack. So the operating system, OS here stands for the operating system. It calls the main. So here in the main function, A is equal to 10, result is still empty, so it's not initialized inside the stack. Then afterwards, when the main calls square, main function calls the square function, then what happens? Main has A equal to 10 and square has X equal to 10. So inside square, X is equal to 10 over there. But when this square is there and the returned is equal to 10 into 10, 100 is returned from that function, that will be stored inside the result. So when the control comes back to this line, which is actually the return address, line number 9. So in that point, main will be still having A equal to 10 and result equal to 100. This is something very, very important. And here the stack is then empty because the main function ends and then the stack is empty over there. So I hope this example is a very, very clear-cut example that you are putting the value of A is equal to 10 first on the stack, then you call another function and then you go back and then you have the same variables which are over there. You only pass by the value or you give the copy of the value over there. Next thing, very important, this is a very simple stack example. I hope you are getting the idea how the stack works whenever a function is being called, and between function, when you call one function and inside that function you can call another function, and inside that one you can call another function. So you can call function over function, function over function. So all those values are going to be stored on the stack, and because the latest function is going to be returning back first, so you will return its variable first from the stack because of the LIFO, that is last in, first out over there. Now, the next very important thing in this slides over there for the function is actually because sometimes you want to generate random number. And for that purpose, the library, which is stdlib.h, is going to be included. Now, this library has to be now a part of your codes from now on, because you are going to use this. In fact, after the midterm, we are going to use this library. It's has a lot amount of functions for strings. It has a lot amount of functions for malloc, or the memory management, or memory reallocation, or basically leaving. We'll talk about that later on. But at present, this library has to be apart from this stdio.h. Now here in this library, there is a function which is called as random, or rand. And in this function, whenever this function is called, it gives you a random number. Now, you may argue, or I don't know the inside of this, maybe I can find it out for you, that what this random function and how it generates. Supposedly, your computer is working on a clock. So based on your clock, based on the seconds trigger, or based on the minutes, you just multiply plus whatever and gives you a random number. So that random number can be 2-digit, 3-digit, 4-digit, 5-digit over there. So you can have, and that's integer. Remember, that's integer. So you have an integer random number equal to rand, and the function returns. So the int is the return type of this function, whatever it is there defined. And then printf over here is going to print that random number, and you can see over there it's just printing because it's a for loop, and from 1 to 5, so approximately 5 times this function will be running here. Only 4 are printed, I guess. So that's the fifth one is missing over there, so that's a typo mistake over there. In fact, it will be run for 5 times over there. So this is a random number generation, and this random number generation is being done over there. A very simple function which you can use for random number generation. Now, supposingly you want a random number between two numbers. Supposingly you want a random number between two numbers, which means supposingly you want to roll a dice. Okay, you want to roll a dice, and you all know a cubic dice has a number from 1 to 6. So it can't take a number of 1, it can't take a number of 7, or 7 more than 6 over there. So it has to be always between 1 and 6. Supposedly you are playing a game between two participants, and you want that dice to be giving you either 1, either 2, or either 3. So very simple trick to do this thing, that whenever there is a random number and you want that random number to be between two limits over there, for that purpose, very simply, always take whatever random is coming out over there and take its modulus, or the remainder operator, with 6. Now, what does 6 do? Remember, whenever you are dividing a number with an integer, the remainder will always be less than that number. So overall, supposedly, if your random number generated is 37, for example, I'm just giving an example. So 37 modulus 6 is going to be 1. So that's always going to be. So if supposing it is 42, 42 modulus 6 is going to be 0. Now 0 is not a part of a dice. So that's why if by chance that becomes equal to 0, that's why you are having 1 plus. So this is a dice roll. And whenever you want to do some random number generation between two digits over there, you have to make it that random number divided by the number of digits, or number of actually the numbers you have over there. Supposedly from 1 to 6, you have 6 positions over there, so you have to divide it by 6. Now, if you want to have a random generator from 0 to 9, you don't need to add this 1 over there, because 0 is also a possibility in remainder. So here you are just having random modulus 10. That is remainder 10. So always the answer would be 0 to 9, less than 1. So the point is over there, and supposedly you want to have a random number from 1 to 100 as well, you can do the same as 1 plus random to 100. So you're dividing that number by 100. So just for example, if supposedly the answer was 184.67, so when you're going to divide it by this 100, or actually the remainder modulus over there, what will be the answer? The answer would be 67 over there, because you are going to have 100 multiplied by 184. The remainder will be 67. That 67 plus 1 would be 68, would be the answer in front of you. So every time, even if you have like a 10-digit number, or whatever number is coming from the computer randomly, again, this is random based on probably the clock which is inside your computer or your laptop, wherever you are having this processor running your C language compiler. So this is, so a generic formula for range A to B is this, that whatever your number is, A plus random number modulus B minus A plus 1. Very simply. So if you want to range from supposedly 1 to 6, so this means 6 minus 1 plus 1. So that is the same thing over there, that is random to 6. If you want from 0 to 9, this is actually 9 minus 0 plus 1 over there. So that's actually 10, and you can see over there 10. So the random number generation is over here like this. Now, This is very simple. You can do this one. You can have a random number generated over there, and you can make some games over there that based on that game, you can find it out. Okay, what you are actually going to try to do that. Next thing sometimes happen that the computer starts giving you, and you are running your program again and again. The random number is being repeated again and again. As I told you, because the clock has 60 seconds from 0 to 59, so maybe the random number is always being generated as 40, 40, 40, 40, 40, or maybe you are having a dice being rolled. So sometimes you're getting six, it sometimes happen five, it sometimes happen four, sometimes happen three. So for to avoid that thing, there is a point over there that is same numbers every time. So just like over there, you have six, six, then you have five, five, then you have six, and then you have six, six, five, five, and you are having this. So this generates the sequence each time because you are taking that input from your processor clock cycles over there. Now, try to find out this answer. I'm leaving that to you, that why random function or RAND generates the same sequence each time. This is something very important. Try to find out its reason. Maybe ask Google, or maybe ask your AI how this is actually going to be generated. I will tell you in the next video, hopefully. Now, when you want to actually avoid this thing and you don't want the same number to be repeated again and again over here, then this is the solution is called as seeding the random generator. Now, if you have played Ludo, I hope so, you have played Ludo over there, and whenever you are actually doing that, so sometimes you want a six, or you want to have a five, or a four, or a three, or something, and you want it. So you rub that, or you actually shake that uh, cylinder a lot, and then have that dice rolled over there, and then you get maybe, and then you're lucky over there. Practically, it is just luck over there, unless and until you are having some physical aberrations in your dice over there, then you can't have that always a six or a one or whatever stuff over there. But here in technical language, whenever you are going to seed that random generator, here what you are going to do, the function is called as srand. Now, seeding means just like you are seeding a plant over there. So here what you are doing, you are using a function called as time using the library that is time.h. Now, I'm not going to go a lot inside the time.h over there. I will just show you on your w3schools.com what is this uh, let me just show you on w3schools.com that if you are talking about your C language over there, and inside your C language, the time is something very, very critical over there. And inside that time function in the library over there, you have a lot amount of functions, but I'm not going to go in detail at present because we have still not found, I have not discussed arrays, how functions occur or how classes are being handled. But just for now, the function which is inside is actually time, and it returns the current calendar time as our second since over there. Now, this is a normally called as Unix time. Just to give you an idea, what is a Unix time over here? A Unix time over there is a date and time measurement widely used in computing. It measures the time by the number of non-leap seconds that have elapsed since 12 o'clock at night on 1st January 1970. So this is actually just like a measure. They have made a standard that if you want to measure a time, the time stamp is 1970, 12 o'clock at night, UTC time over there. And that is called as, so you measure the number of seconds. So supposedly, let's say I have the Unix time. This is a very simple link over there. I'm just trying to tell you. So what is the current timestamp over here? Supposedly you want to find it out. You can see over here, seconds since 1st January 1970. These are the seconds which have passed over there. So in this function, it returns the current calendar time as this value second since over there. So when you are going to put some function in this time function here in this example, let me just go back on the slides over here. Sorry on that part. So you have this time over there, and in this time function, you are putting null. Now null is empty over there. So you are seeding over here, you are putting a null value over there. So by over here, what will happen every time when you are going to have the rand function coming up over there, then this is always going to give you a different result over there. You can try this one over there. So you only have to try at once at the start. So you are actually telling the C compiler that the seeding srand function is actually going to be just for the seeding, and you are telling it that the time which you are getting inside is null. Remember, what it does practically inside, I just told you just now 2 3 slides back, that it takes the clock from your processor takes that time, and then gives you the random number. Now we are actually telling it that don't take it, take null value. So based on some process, it gives you, I'm not going to in that detail. In fact, just like a question or assignment for you, try to find it out that how this random number actually works. And if you give this one over there, what happens or what is the difference over there. So now we're going to run it and you're going to get different answers every time. So it's not going to repeat and every time over there. So this is something very, very important. You are actually seeding the random number generator over there. Now, the next thing over there is, and I will discuss it more after your midterms over there, but just now, just for this chapter number 5, because it's very important over there. One is called as a local variable, another is a global variable. And to understand this thing, let's go on one example over there, which I have over there. And this example is something very, very important. And I want you during this lecture to find it out. Now, if you see over there, in this function, you have stdio.h, a normal function. You have a prototype over there. It's a function. The function name is mystery, int a, int b, two parameters over there running inside it. And inside the main function, you are taking just two inputs from the user, which are two first integer and second integer over there. And you are just going to display on printf over there mystery x comma y. Now it's called as mystery because it has not been told that what this function is actually doing. Now, if you see this function over there, very carefully inside this thing, the definition of the function over here, int mystery brackets open int a comma int b, and inside it, here there is a base case and then there is an else. Now, this is something very tricky, and this is going to give you a concept called as recursion, which is going to come up just now after this local and variable slides over there. The next thing is recursion, and that is actually the main part of today's lecture. For that's why I'm actually recording this thing. And over here, if you can see what is happening, what is recursion? Recursion means that you are going to call the same function inside that main function, which means supposingly you have a function and it multiplies supposingly two numbers, and inside that function you again call that function and you again multiply two numbers. So here in this function, apart from this if statement, there is an else statement, and inside that else statement you can see what is there, return a plus mystery a comma b minus 1. So you are calling inside the main function, or not the main function, actually the function. You are calling the same function, but with a different parameter. Now, for example, let's say, for example, I had two numbers input inside this program. Now, see this very, very carefully, what I'm actually trying to tell you, and this is, you will understand the concept of recursion very easily. Supposingly, you have x equal to 2, y equal to 2 entered by the user. I will show you this one also, but before running this program, I want you to understand what is this recursion. Supposingly, inside x and y, you have saved 2 and 2. The function calls 2 comma 2. Well and good, no problem. Function is now here. It goes inside this if else statement. If b is equal to 1, no, because I have 2 comma 2. What will happen? Else command will be there. Then return a plus mystery a comma b minus 1. What is happening? What is a? A is 2. Another function is being called, and this time it is having parameters 2 comma 2 minus 1, which means 2 comma 1. So now another function will start, and the variables inside this function will be put onto the stack because it's LIFO. And again, this function will be called with this time 2 comma 1. Remember, the return was 2 plus that function. So that 2 is still there and it's waiting for that thing. So what is going to happen? Then it goes to this one, 2 comma 1, and then it comes back on this condition. Yes, now b is equal to 1. So what will happen? Return would be a. So that function will be returned. It will not call, it will not go inside the else statement. It will give you return A. And when this thing returns to you, so what will be the returning for the first time the function was called? It will be A plus A. What will be the answer? What was A? A was 2. So the answer would be 4. Now let's run this and give me this, give us the same thing over there. And I have two positive integers. Let's say 2, enter, 2, enter. The result is 4. So what is happening actually? Let's say if it was 3 and 3, two numbers. I'm just keeping the number same at present. So let's say if I run this again, 3, enter 3, and it's 9. What is happening? The happening is this, that when the first time the function runs, answer is here. When the first time function runs, let me just give you, when the first time function runs, the return is a plus. In fact, just me give you answer. Return is mystery 3 comma 2. Then afterwards, the next thing is return 3 plus 3 plus 3 plus mystery this thing. And then you have uh, over here return 3 plus 3 plus 3. So what is happening? The first time this function was called, it came inside this function and it came to this else statement, and here it was return 3 plus mystery 3 and 2. Then this function was called. When it went inside that function, again it was having a return statement this time, which was 3 plus mystery 3 comma 1. So here you can see this 3 is from here, this 3 is coming from this thing, and when this one comes over there, the return, because here this time b is equal to 1, so it comes over here and return a, so this becomes 3 plus 3 plus 3. So what is actually happening? You are having 3 multiplied by 3 over there. So this mystery function is basically doing multiplication. Now, just to verify my claim, let me just save it, run it again. Sorry about that one. Actually, again, that I've done some mistake. No, no. Again, that AI 3 stars are always coming in. Okay, let's see. Now I'm now changing the number. Let's say I have 5 and I have 3. You can see now it's 15 because a is equal to 5 and 3 times that function is called. First time when, sorry, b is a is 5, b is 3. So what happens? You call 3 times that mystery functions, and every time that function returns a, and the last case it returns when b is equal to 1 a over there. So what is this doing? This is just multiplication. And this type of functions where the function is itself calling itself is called as a recursive function. Just to give it a more answer, again, sorry, I don't know why this AI actually comes in and that blob bulb or that stars. Let's say I go to 10 and I put it like something 4. You can see the answer is 40. So this mystery function is actually the multiplication. And here you're not using the multiplication operator. Remember, you are just adding return a plus, calling the same function, but with. Now here, there is a trick. The trick is this, that when you are making it b minus 1, when you are making it b minus 1, that actually does it. So a point will come when b will be equal to 1 and the function will be the last function, because then it will return. If b is equal to 1 is not there, then this function will never end. It will go inside an infinite because the function is calling another function. An extra function is calling another function. A function is calling another function. It will never end. But here this time, when I'm calling 3 comma 3 or 3 in x, 3 in y, and I'm putting it in a and b over there. So this means the inside function is going to be called 3 times. So 3 into 3 into 3, practically it is 3 plus 3 plus 3. That's why 9 was being printed over there. So this case where the function actually ends and does not call another function or a copy of itself, this is called as the base case. This is called as the base case. This is very important. So a recursive function, you always require a base case, and that base case over here is this b equal to 1. Remember, this is a must. If you're not going to have a base case, your function will never. Let's say, for example, let's say I call it b equal to 0. Not x 0 equal to b minus 1. Let's say b is equal to 10. I just put it 10. Okay. And now I'm going to now see what happens. It will go inside an infinite loop because now I'm going to give it a value of 3 and 3. Now what will happen? It's a segmentation fault. There is nothing happening over there. So you are not going to have any answer over there. So here the base case is not there. So if you want your base case, supposingly, let's say I put the base case equal to 0. Let's say what happens. What is the answer? Now here If I put 3 again, now you can see what is happening because it has run 4 times, because the condition is equal to 0. Because every time b minus 1 was being called, so still this goes on up till 4 times. So that's why 3 plus 3 plus 3 plus 3. But I want 3 plus 3 plus 3 only 3 times. So that's why I will have to make it back to 1 over there. So this is a very classic case of recursive functions. And that's why it is called as when a function calls itself. Okay. And there are two essential parts. One is the base case stopping condition, because stopping condition means that it's not going to call itself again. And the recursive case, the function calls itself with a simpler problem. Simpler means you are reducing one variable or increasing or whatever you are doing over there. So this is one way. So two essential parts of a recursive function is this, that you are actually going to have a base case and a recursive case. Now, coming before I proceed on and give you through some examples over there for recursion, because that's actually the main thing for this recursive over there. What are variables over there? Now, I've come back on this code over there. Now, in this code over there, if you see over there, this variable int x and int y, they are only inside the main function. I cannot use them inside the other function, which is mystery over there. So these int x and int y, they are local variables. Remember, they are local variables. Similarly, here inside it, I have int a and int b. I cannot use them over there inside the main function. For example, let's say I write down over there and I ask it, okay, this time write down a over there. Okay. So identifier A is undefined. So you can see what is happening. It does not define, it does not understand from where A is coming. But if I write down X, yes, it will define it out. It will never understand where B is coming from. Again, see, you can say identifier B, because B is not a part of this function. So whenever you define a variable inside a function, it can only be used inside that function. You cannot use the variables of main inside this function. And similarly, you cannot use this variables inside the main function. Now, supposingly, if I wanted to use inside this function also and this function also, then I have to make a variable which is going to be, let's say I call it as a global equal to this. And I have defined this one over there on top of everything, above the main function. Now, this is a global variable. Everywhere it can go. So you just like have a universal passport and you can go anywhere, wherever you want. So now if I want to now, supposedly the global variable, let's say I want to call it a global variable is this one. Now I can print this here also. And let's say I want to print this here also at here. And I run this command. Let's see how this runs over there. And if I now have 3 and 3, you can see the global variable is 0, 0, 0, 0, 0. It's always being printed. So global variable can be accessed everywhere. That's the main thing. And this is the exact main difference between a global variable, and global variable is defined on top of every function, every main function or any functions inside your code. So here you can see the global variable is equal to 100 and it is being accessed here. It is being accessed here over there, and you can see, and you can change its value anywhere. It will be changed. So here, if it is 100, inside this function, it is 200. So when you are going to call function number 1 over there, the global variable will change to 200. And when you call function number 2, this time it will be again 200 over there, because it's a global variable. So this is a very classic case of a global variable over there. Now, apart from this global variables, there is another case which is called as static local variables. Now, what is that? Now, this is something very, very important. I'm not going to touch it very detail. I will give you a small part, maybe probably after the midterm, but just to give you an idea, whenever inside a function, now listen to this very carefully, whenever inside a function, I am declaring a variable and I want that variable to be retaining its value whenever that function is again called. Now see this very carefully. Whenever that function is again called, it will be reinitialized to int count equal to 0. But I don't want that to happen. I want it that first of all, that function was called Whatever the answer was, supposedly it was 1, 2, whatever, it retains that value and next time takes that value as the initial value. So here you use the word static. What happens? It will not now initialize it back to 0 because again the function is being called. So what will happen? When first time the counter was called, what happened? Initially, it was initialized only once. Then count plus plus, it was initially 0. So now it was made 1. And one printf will be there, count will be 1 will be printed. So here count 1 will be printed over there, as you can see in this comment. Then afterwards, you again call this function. Now, technically, if the static word was not there, again 1 would be printed. But since you have used the word static, static here means that the variable is not going to be initialized. It's already there and its value is saved over there. It's not going to change. It remains on that stack. Whenever it comes on, it is there. So then count plus plus, then this time count is equal to 2. And then afterwards, again, you call it, you have count equal to 3. Even if you do it like 10 times, it will keep on increasing. So if you want to keep your variable safe inside functions, because local variables can't be accessed, then you have to use the word static over there. Okay. Can you try to play with this thing? I'm not going to give you an example over there. Can you try to play with this thing? What is here the word static doing over there that you are actually only going to have it initialized once whenever that function is called, and then afterwards its value will be restored every time whenever that function is there, and it is not going to change or reinitialize back to its original value. So this keeps its value between the calls and initialized only once over there. So I hope you have an idea what does this static variables means and what does this global variable means over there. Okay. Then coming back to recursion, because recursion is our main course for this over there. Now, just one example over there, you can see this example, something very easy, something very, very easy. You can see over there, main function is nothing. It's just a function is being called with 5 inside it. And when this is called, if n is equal to 0, blast off. This is the base case. This is the base case over there. And what is happening actually? Printf n is being printed. Whatever value is coming, so 5 will be printed first. Then afterwards, countdown. Same function is called, but with a reduced value. So after 5, 4 will be called. Then after again printing 4, 3 will be called. Then after printing 3, 2 will be called. Then after printing 1, again it will be called and 1, and then afterwards this will be printing 5, 4, 3, 2, 1. But at 0, when 0 will be there, it will not go here, and here it will come at if over here n is equal to 0, blast off, and here it will return. So inside if statement, which is the base case, you have to return, because if you don't do this return, it will go on and keeps calling the function again and again. It will go in inside an infinite loop, and then it will be an error for the compiler. It will never compile it. So that's why a base case is always required. So you found, called the function countdown. So it prints 5, then countdown 4, prints 4, countdown 3, prints 3, countdown 2, prints 2, countdown 1, prints 1. Now here this goes to the base case. So it prints blast off. So 5, 4, 3, 2, 1 and blast off will be in 5 different lines because you have a escape character also over there. So this is working over there. And again, one more example which you can do very easily, and we have done this one factorial by using for loops up till now, but this can be done by using recursive, and that is the factorial. So if you are asked to make an algorithm for supposingly 5, so this means factorial of 5 means 5 into 4 into 3 into 2 into 1, or you have 0, then it is equal to 1 by definition. So you are easily getting it that if your number inside this factorial, now here this is long, long. Remember one thing, long, long stands for extraordinary, I guess 32-bit numbers over there for integer. So here the return type is long, long. And remember why unsigned? Because factorial is always a positive value. Factorial is always a positive value. We always take it for the positive values over there. So inside integer n, you have if n is equal to or less than equal to 1, because it can be 0 also, because there can be a 0 input as well, because that is also possible. Then by definition, this is by definition. Remember, 0 is already 0, but by definition, we have made factorial that 0 factorial is equal to 1 always over there. So if n is less than or equal to 1, then return 1. Else, if the number is 5, 4, 3, 2, then return n into. And what is n? N is that number which we have put. Supposingly, now you have put n 5 over there. So you put return 5 into factorial of 4. Factorial of 4 gives you 4 into factorial of 3. 3 gives you factorial 3 gives you 3 into factorial of 2. Factorial of 2 gives you 2 into factorial of 1. And that 1 over here means return 1. So what will be actually happening? Return would be 5 into 4 into 3 into 2 into 1, and that will be return answer. But if you don't give this base case, then this will be never completing. So in this just small function, without any use of for loops or something, this is called as recursive function. And here you are actually calling that recursive function and you are doing that functions over there. So very easily you are having the functions being called itself over there, and you have this factorial being printed. And I guess they have the answer over there. When you have the 5 factorial, this is 5 into 4 factorial. 4 factorial means 4 into 3. So this will be 5 into 4 into 3 into 2 into 1, and you have the answer 120 over there. So that 120, whenever this function, whatever that name is, factorial. So inside the main function, you call this factorial, and inside it, you write down 5. The return would be 120. The processor is going to call its function again and again 5 times and give you the answer of 120 over there. So it will be over there. Danger, as I told you, never miss the base case. That is very important. So functions keeps calling itself, the stack overflow error over there, and the program crashes over there. So this means always remember, have a base case and make sure you reach the base case. Don't have some ambiguous if else statements over there that it does not reach the base case over there. So a base case is must over there. Each recursive call should be simpler. Simpler by means that here, whenever you are going to call it, it will be n minus 1. So you are going to have a positive integer, and that positive integer will be always reduced by 1, 1, 1 every time there. So supposingly, even if in the factorial you put 20, you put int n, and here in the parameter you put 20. So it will run for 20 times, no problem with that. 20 into 19 into 18 into 17 into 16 and so on up till 1, and it will run and it will give you the answer. Even if you give it 5,000, even if you give it 5,000, the factorial will be there, and that's why the data type is long. Okay. So I hope you are getting the point over there, that's why this is long, because 500 into 4999 or 14 or 500 into 499 into 498 into 497 into 496 and so on up till 1. That will be a very long number, and it can only be stored into a 32-bit integer number. That's why it is long over there. So here, remember, do not miss the base case. They are a must whenever you are trying to find out. Now, I will just go through some problems over there. There's some problems over there, and I'm not going to go everything, but these are very something important. If you want to write a function to find the maximum of two numbers, now here, what is happening? You have the prototype over there. You have the main function over there. Again, this is just finding out the maximum of two numbers. It's not recursive. So you are just having 25 and 40. If the two functions are there, return is there, else over there. It's a very simple problem. So I guess it's not self-explanatory to understand because you have done a lot of programs up till now. Now, again, you can do that for check even and odd. Again, you are calling a function over there that is even over there, and inside that is even, I guess is I guess that function is missed over there. I guess from here it's missed over there. But again, if you want to check on that if it is even or odd, you can divide it by 2 and find out if the remainder is 1, then means it's an odd. If it is remainder is 0, then of course this means that it's an even number. I guess that's something very easy. And here the function call is even, and inside you are putting a number over there. Then you can do a very simple conversion for temperature converter. Again, this is the function, and you are having double, remember, in temperatures, because points are very important. So you are having a double data class over there, and here you are returning Celsius into 9.0 divided by 5.0 brackets close plus 32.0. And this is the function prototype over there. Remember, in function prototype, do not miss the return type, the name, and whatever is the parameter that are must over there. So this is the must over there. So your output will be 25 degrees centigrade to 77 degree Fahrenheit over there. Then functions with multiple parameters, I guess we have already done it in the last part as well. So nothing fancy. You're just having the calculating the area of the rectangle, length into width over there, and the return is the length into width over there. So nothing fancy. It's just printing you that length and width over there, and you are calculating the area. The function is being called inside the printf function over there. So these are very simple examples about how your functions are being used over there. Here you are using the math function over there. You can see over there you are using the power. So this is actually 2 raised to power 3 over there. So you are hatching base into exponent using loops over there. So here you are using that for using this thing. So you can have your result over there and you can print it over there. So you have this function prototype over there, that is power over there, int base. Sorry, this is not using the math function. You have implemented your own power function, and that power function is over here implemented using the for loop. Okay, so you can implement your own. Sorry about that. That was actually POW, the math function over there. Here, this is power 2 raised to power 3. Here, this is 5 raised to power 2. So the answer would be 25. Sum of digits, we have already done this one in your Armstrong over there. Very simple one. So here you can have 1, 2, 3, 4 divided by whatever the number over there. And all this thing is being done inside. So same thing, while number is greater than 0, you divide number by 10, you get the last digit over there, you sum it inside your sum over there, that is actually 0, and then you return that sum because every time that sum. So when you are going to divide 1, 2, 3, 4 by 10, the remainder would be 4. Add it into sum becomes equal to 4. What is the quotient then? 123. 123 divided by 10 again is the remainder is 3. So 4 plus 3, 7. Then the next thing, 7 plus 2, 9, 9 plus 1, 10. So the answer would be 10 will be displayed finding the sum of digits in a number. Please again remember, all this thing has to be done inside function, so it becomes easy, because here when you are having the sum of digits in this one, so this the function is being called over there, that is the sum of digits into number over there. Very importantly and very important, that is a prime number checker. And this prime number checker, kindly go through this program. I'm not discussing this over here, but a prime number which cannot be divisible by any other number except itself over there. And you can see over there, you have an if number is less than or equal to 1, then return 0, because of course that number, if it is 1, then this is going to be 0. Then certainly you are not going to have that number as a prime number over there. Then over here inside it, you can see over there from 2 to I into I is less than number. So what is this? I over here is that number which is you having, and it is less than that number over there. So kindly go through this code over there and try to run it on. I'm not going to explain this one over there, but this is something a very, very important number, how you can actually find out a prime number over there. Then very importantly, because we have just done the recursive things over there, the recursive sum over there. So sum of numbers from 1 to n. So if you remember, we have done this previously in the first few lectures. We use for loop. Here, very simply, recursive does it in 2 or 3 lines. So base case, if n is equal to 1, return 1. Otherwise, return n plus sum n minus 1. So every time there is, supposedly you have put inside this function sum and you have 9. So it will be 9 plus 8 plus 7 plus 6 plus 5 plus 4 plus 3 plus 2 plus 1 plus 0. Not 0, actually it will be just 1, not 0, because this is base case is n is equal to 1. So here when you are going to have a sum of 1 to 5, so this will be sum 5. So it will be running for 5 times. 5 plus 4 plus 3 plus 2 plus 1. That's all. Similarly for 10. So this is very simple. So recursive functions or recursion actually makes your life very easy. You don't even need for loops. Your compiler is actually going to call the function itself. And that's very simple work over there. Then if you want to have the function of printing, I guess we have already done this one already. Have spent a lot amount of time on this thing. So it's nothing fancy. Menu driven calculator, you have already done this one in your lab up till now. You have done the add, subtract, and multiply. So it's nothing fancy. You have 3 functions over there on the top, and every time you are calling this thing over there in this function. So these are 10 problems over there, and I will strongly advise you to go on this chapter number 5 on the link I have already given in this lecture also. Kindly go through these commands over there. Sorry, lecture number 5 I'm talking about. Yes, this one. Here you can see on this one actually. Yes, this one. You have this random number generation over there. the dice rolling over there, and then you have this one. So you have a lot amount of programs inside this code of your chapter number 5 over there. But as far as those time is concerned, or std library.h is concerned, there are some functions which I have not discussed. Yes, I will discuss them when we are talking about the strings or the memory arrangement and all that stuff. So leave that to up till over there. Now, just to conclude this one over there, if I just go on over there, please do not forget the semicolon in the prototype. This is something a common mistake. Here, if you, this is a function. Remember, this is a function, it's not a prototype. But here, this is a prototype because here you have a semicolon over there. So if you miss this semicolon, you are going to have an error. So what happens here, this will take as a function and this has no body inside it. So it's a missing semicolon over there. So this is the correct way. Always put the semicolon, and then afterwards at the below of that main function, you can have your function body or the function definition written over there. Then type mismatch, also one of the big problems. Here you have defined it as int, but here you write it on double, which is also a big problem. So the correct is it that if you have in the prototype double, then again do that also double whenever you are having that return type over there. So this is very something important. Then very important, if you have a return type int, please don't forget have a return. Okay, so you have to have some thing returned over there. Otherwise, if you don't have something to return, then put down the statement void over there. That is also very important. Then wrong number of arguments is a very common mistake. We will have this one. At present, you are just going to have 1 or 2 arguments up till now. But a time will come when you will be having like 10 or 20 of arguments inside it, and then mismatch comes occur. Here you have 2 arguments, and here you are just adding 1. So this will not compile. This will be a compile error over there. Then modifying parameters and expecting change. Here you can see over there, this is int x over there. So what happens over there? It will be still 5 and not 6 over there, because here you are actually inputting 5 over there. So when you are going to have x is equal to x plus 1, so this x copy will be only changed locally. Remember, it will be only changed locally. So when you're going to print it over there after the function, it will still be 5 because it's a local variable over there. That x is a local variable. It's not inside this function. But if you want it, then make x as a global variable outside the main function, outside where you have made the include statement, just pass it. Then you can access that function. And when you have changed it, then you can access it over there. Even remember, making it static, we won't be able to run it inside the main function, because static only makes it retain that value, but only inside that function. So this is something very, very important. So if you want to do something like that, make it a global variable. But remember, global variables take a lot amount of space and they are hungry for the space a lot. So never make global variables beyond some one threshold over there. Then I guess this chapter is almost complete. There are some function design principles. Kindly you have to get it on over there. Whenever you are making, don't minimize the parameters, avoid global variables. As I was just telling you, keep the functions short as much as possible. Smaller functions, much better. Meaningful names, as I have told you, and single responsibility. That means that if you are making a function, if you want to multiply two numbers, just stick to that number. Don't have that they are also multiplying, they are also subtracting, they are also having addition. Don't make different works being done by the same function. That actually makes it difficult to understand when you're going to come back to your code. So meet these 5 functions design principles. They are very much important over there. And I guess this is all over there. And these are some of the exercises. And these exercises, please do them before any of your exams over there, because these exercises give you a lot amount of in-depth algorithm development. For example, let's see over there in number 6, write a function to print your name n times. I guess something very easy. Write a function to check if a year is a leap year. I guess you can do it very easily, because based on your number of year, supposedly we are in 2026 over here, you can find it out it's a leap year or not. Similarly, by dividing it, of course, by that number. Writing a function to find the larger of two numbers. These are very simple codes. You have already done it. They're basic functions. Then again, if you are asked to reverse the digits of a number, first of all, you have to find out the digits and then you have to reverse them. Of course, you can do that. Very easy, nothing fancy over there. Write a function to count digits in a number. You have already done it one. How many numbers are there? You can sum the digits of a number. So these are some of the more challenging problems over there. And then these are the recursive functions. And I will strongly advise you to go through these functions over there, which are recursive in nature. Here, factorial, you already done it. We have the calculator of the x raised to power n. We already done it in the examples. We have also calculated sum 1 to n. Fibonacci series is also something very, very easy, nothing fancy inside it. Just these last two, three ones are a little difficult. In fact, only the last two are a little difficult. The remaining ones have already been done or already been discussed inside it. But remember, always identify what is the base case. That is something very, very important over there. So this is all for this part. I hope you have understood what we have talked about in this one. Main point of this one is recursion or global variables, local variables, and how to make a local variable as static. As I've told you previously, that if you want to make that variable retain its value whenever that function is going to be again called, that is called as static. And this is all for today. And we have talked about the stack, which is a very, very important factor for this chapter number that is over here for functions in C language. I hope you have liked it. Thank you. Allah Hafiz.